Hello, welcome back at the recap conference. We're now at our final session, and the topic is one query language to rule them all. We're happy to have Vitaly and Matthias, Vitaly Kozyura and Matthias Schur with us for the last session. So both have some impressive history in their biography, starting from research and being active, Vitaly, in web analytics and web IDE metering and reporting. And Matthias was in research and working with model mining, model-based testing, and web analytics. So we have the virtual stage set up. Video works fine, sound works fine. And so I hand over to you two. And good luck. Thank you.
Thanks. So let me first share my screen. Let me know if you already see my screen.
Yes, looks good. You see, I think, the presenter screen of you. So with all the colors and
nice.
That's fine.
So I can start.
Yeah.
So my name is Vitaly, and my talk is about the query language, which is used in CAP applications for both Node.js and Java. In my talk, I basically tell you about the Node.js part, how to use the Node.js API. And in the second part, you will hear about how to do the same in Java language and what's so special about the Java. Okay, so the agenda is the following. First, I will give a short introduction to the query languages, to the basically query language CQL and CQN, which was already mentioned in the previous session. Then I will show you the core of the query language. So these are basically the CRUD operations, select, insert, update, delete, followed by some advanced features like expand and subselects, which you can also build in the query language. Then I want to show you a few very small Node.js examples of how you can use the query language in some practical examples. And I will conclude with a few resources where you can find further information. So first of all, the query language CQL. I think you already have heard this name in the previous session. So this is a human-readable query language which is used as a core query language in the CAP development. And on this Kapaya documentation page, you can find a nice description of it. You can find here projections, you can find path expressions, and a lot of nice features, which makes it really easy to use and very human-readable. And in my talk, I will also show you a few examples, but the detailed information of this language, please, for detailed information, please take a look at this page. And the same is true also for the CDS query notation, the sequen. This is a JSON format, again, for the same query language, but this is no more human-readable format, but this is a format which we'll internally use in our application. And again, I will show you a few examples, also how you can efficiently build this sequen object using the Node.js API. But for details, please take a look at the Kapaya page, which I'm showing you now.
Vitaly?
Yes?
Can you hear me? Just one thing. At the moment, you are sharing your, I think, second screen. So it's a presenter screen, and we just see a part of the full screen mode. If it's possible to share your other screen, then the whole thing would be larger and the text would be more easier to read.
Okay. This is also somehow strange how I can see this here. I've never seen this.
Okay. Do you have two monitors on your?
No. I'm just started sharing, and
yeah,
there was
maybe.
Some...
So the sharing.
So you can, if you can give me a hint.
share the desktop and not the PowerPoint application?
Yes, I'm sharing the desktop now.
Okay.
Is it still partially visible?
Yeah.
Yeah, it's just the, yeah, we just see a part of it. So maybe stop the presentation again, end the sharing.
Yes.
And then we try it again. Hopefully this works out.
Okay, thank you for pointing to this. Maybe I will try vice versa. I will try to share the application because I was sharing the desktop.
Yeah, we are free to experiment how it works best.
Okay.
Yes.
What can you see now?
That was once short before there was a, yeah, this is a slide. One is a browser. Is it a browser or is it a slide?
No, this is a slide.
Okay, then we see it full screen now. We made it.
Okay, thank you for pointing to this. Sorry for confusing you. As I mentioned, these are 2 pages. Then probably I can quickly show them again. This is the CQL and CQN pages, which are nicely documented in the Kapara documentation, where you can find all details. And this is a kind of introduction what I want to make here. So in the central part here, you see the CQN format, which, as I mentioned, is used in the CAP application as a kind of central internal format for queries. And on the left-hand side, you see that the CQL is one of the input language. It means you can easily translate CQL to CQN. But you also see in the first line that CQN can be obtained from OData or REST requests. And this is basically what is happening inside of the CAP application. The request is translated into this internal representation, and then you can do something with it. And what you can do with the CQN, for example, you can translate it back to OData or REST request and resend it to another internal or external service. You can also extract some part of it and resend it to external or internal service. And another output options, which you also see on the right side, is to produce an SQL expression. And with this, you can, of course, execute your SQN query on different databases. Currently in Node.js, we support HANA and SQLite. But you have seen in the previous session there is also work in other directions for other databases, including also NoSQL databases. So in this sense, one can say that this CQN format is database and service agnostic format, and you can use it also like this. But then on the left-hand side, the last point is query API. And this is the main point of my presentation. So what I want to explain you is how to use the Node.js query API, and in the next part you will see also how to use the Java query API in order to produce the CQN JSON objects in a nice and efficient way. Here are a few examples. You see here a simple SQL statement saying we want to select data from the entity called authors with a simple condition saying ID is equal to 1. And on the right-hand side, you see the CQN representation of this request. This is the internal format which we use inside of our CAP application. And again, on the left side below, you can see here the query API, which is a very short statement how you can create this whole CQN by just taking the select object, which is usually provided in your custom handler, or which can be easily required if you create your own Node.js application. And then you just call the method from, having 2 parameters, name of the entity and the key. And that's it. With this simple statement, you can create the CQN on the right side. And this is basically what I want to talk about, how to use the Node.js query API and how to create the CQN statements and how to modify them. So the recommended way for creating and modifying the statement as a CQN queries is to use the query API. I don't want to explain this slide in details. This is just overview of CRUD operations and how the corresponding CQN JSON objects look like. Here you see select, update, insert, and delete, which do exactly what is written here. So you have some parameter, you have some object properties here, like from and where in select, which entity you want to update, and with which data in update, and so on. And this sequence will be created using the API. And before I start, I think I have here one more slide. This is my running example, CDS model, which I want to use in all my examples. This is a very simple one. You have books and authors. Both of them have keys of type integer, and some more properties like title or name. And if you look in the authors entity, you can also see that authors is composed of a number of books. And of course, an author has a number of books which he or she has written. And this composition is composition to many in this case. And this is my running example. So let's go and let's see first the method from, which I already mentioned here. And actually this first example is exactly the example which I already presented, where you want to select all columns from the entity authors with a simple where condition, and just write in the query API, select from with two parameters. The second parameter is optional. It means you can just take first parameters, and then it will be equivalent to select star from authors without any condition. The second example is also not so complicated, not so complex. You see here it's the same, but in this case I'm only interested in the name column, which I want to select from the author's entity. Again, with the same condition, ID equal to 1. And for this, I can again use the from method. But in this case, I will use also the third parameter, which describes which columns I want to select. And this you can do in different ways. Actually, also as providing the key. I will mention this later. Also for providing the key, there are different options. And each of those options has different advantages and disadvantages. In this case, I describe the column I want to select with the help of the so-called arrow notation. Arrow function. And in this arrow function, you see I describe some parameters. And in this case, the only parameter I describe is name. So it means I want to have the name column selected. There's also another possibility, which you also will see later, to select columns, just provide name of the column, and both these options have advantages and disadvantages. For example, if you just provide the name of the column, it's very simple. But in the case of arrow function, you can, for example, write in a very efficient way expanse and even the deep expanse. And wait until I show you the advanced part of the talk. But this is still the basic API. You can also use the columns method, which is doing mostly the same as the third parameter in the from method, but this is a separate dedicated method where you can explicitly describe or add the columns to existing sequence. So you can also use method not only for create sequence, but also for modify existing sequence. And in this case, you see this exactly these two options for providing the columns. First one saying I write arrow function with two parameters, ID and name. And in the second option, you see it's just a flat list of strings describing ID and name as strings. So these are basically two options how I can provide columns. And okay, here are a few more select options, which also implemented as separate methods in the select class. So you see here, for example, if I want to select one from authors, just use the method, which is called one. And if I want to select some distinct entries from authors, just use the method, which is called distinct. It means if I want to have like first names of the authors and they can be repetitions, then I can use this distinct statement in order to select a distinct set of values. By key is another alternative to writing the key inside of the from method, as I already shown you. And here you can write the key in two different ways. And I mentioned you also in the from, you actually can write this in basically these two different ways. You can either provide directly the value, or you can provide object having the key value pair. And what is advantage of the object is in case of composite key, or if you have multiple keys, then you can use this notation to provide all keys. And the advantage of this one is, of course, the simplicity. Just write your value here and that's it. So in both of these cases, the meaning of this by key expression is the where condition, which you can see above in the SQL statement. It's still the same SQL statement where I select from authors with a simple where condition. So this is a bit tricky part. Not all conditions are so simple that you just say my keys are like this and that. In some cases, you also want to formulate a more complex condition. Okay, this is what I have here in my SQL example above is a bit artificial. It's some abstract condition, but it still says something. And it says like I want to have authors with a special name, which is name in this case. And the IDs should be either 1 or 2. So this is a bit complex condition that I have. And in this case, I have two possibilities again to express this complex condition. Both of them has their advantages and corresponding disadvantages. And let's start with the first one, which is called object predicate. So I can insert into the method, which is called where, as a parameter, an object having a number of fields. And the rule is all these fields are combined with and. It means in this case I have a name is equal to name and something else. And this something else is again a keyword, which is or. And this keyword means everything that is inside of the array, which is the value of this or, is combined using the or operation. Then you see inside of the array, we again have objects. And this is, of course, a very nice way if you have nested, deeply nested conditions with and or. And in this case, you can, in quite natural way, formulate your sub-objects. You can again create multiple fields which are connected with and. You can insert further or conditions. And you see in this case, it's quite easy to produce nested complex where conditions. Another notation, which is below, is a so-called fluent notation. Here you have a flat structure, not nested anymore. And in this flat structure, it's exactly the same where condition that you see above in the SQL. But in this case, you just write it in a flat way in the alternative way. So you just write it in the way where you put strings on the odd places and values on the even places, let's say so. And you see here, for example, on the first place, you have name equal, this is some string, and you put your value on the second place, on the even place. Then on the third place, you again have some string, and then you put your value on the fourth, again on the even place, and so on. You have your string here, and you have the value on the even place. And then you conclude with the odd place where you have the bracket, the closing bracket. What is advantage here? First of all, this is flat. You see immediately what you are building. And then you can, of course, do something more complex, like you can create, for example, subselects and just place the subselects in the even places where the values are placed. And in this case, you have nice possibility also to include subselects. So I will also show you later one example having subselect. This is the so-called fluid notation, where you can combine different wheres after each other. And in this case, I'm not only using the where method, but I'm also using the method which is called and another method which is called or. So basically, the and method doing the same what the method where is doing. It connects the next condition to the previously built one using the AND operator. And the OR condition is connecting the statement, which is inside of the OR method, to the previous one, again using the OR operator. And if we see at whole the structure, we first define some where statement, which is basically copied from the previous slide. Then you decided to edit some more conditions. One is with AND, another one is also with AND. And then you decided also that you have some alternative, and then you edit another method which is called OR with some condition inside. So what is also so special here is this AND method, because if you look inside, you see that this is again some other notation which I haven't explained yet. So the first where has object notation, the second where has fluent expression, the last OR also has fluent expression, but this one I haven't explained yet. And this is a nice possibility if you already have parsed sequence with some where condition already parsed in the sequence format, then you can just take this where condition and put this into the where or into the AND or into the OR method, and this already parsed condition will be just taken to this expression and connected with it using the corresponding logical operation. So in this way, you can incrementally create and extend your conditions for your sequence queries. Group by and order by is quite natural. You have the possibility always to group by some column or number of columns, and you have possibility to order by also by some column. And in this case, you see we have a dedicated method for grouping by and for ordering by, which are called exactly like this, group by and order by. And it can have also more complex parameters that is this presenting here. So please take a look at into the documentation. The statement, the parameters of this group by method, for example, can be a bit more complex than just providing a name or a few column names. Having. This is what you typically would use together with group by. And from the parameter point of view, this is exactly the same as where method, where you can use object notation, you can use fluent expressions, which is what is done here. In this case, you see it's some fluent expression having on the first place a string and the value on the second place. And you can again provide having condition which you already have in your statement as array, and this will also use it here in this function. And another one is limit and offset. In the SQL notation, you have two keywords for this, limit and offset. So you want to limit your result set and you want to do some offset inside of your result set. But in the query API, we just let one method, which is called limit. And this method takes two parameters, limit and offset. So you can use this one to create the corresponding sequence also with limit and with offset. And actually that's it about select. So now I just quickly go through the remaining CRUD operations. So for insert, you see here we have possibilities to insert objects. You can write entry data into the object notation, but you can also write your entry data in the array notation and provide it either as a single value as a single array, like split it here as values, or as number of arrays here. You can also provide columns, and providing columns here is optional. If you do not provide columns, then it means just all columns will be taken in their corresponding order as they are defined in the table, and the values you'll insert it exactly in this order. And these are two alternative ways how you can use insert. And actually, that's it for insert. There is another CRUD operation update, and here I will show a bit more. Okay, this is very simple update. You just say, okay, I update by key. This is what you already know from the select, and I want to update only the column which is called name, or only field which is called name, and set it to some changed name. But the interesting part is the next slide. So here you see I can also update, so I can also do some deep update. It means the authors, as I said already, authors is composed out of a number of books. So it has a composition of books which he or she has written. And I can also update authors including the books. And if the books would also have composition of something else, like editions and all, then this deep update can be arbitrary deep. So in this case, it's just one level, but in general, this can be a number of levels. And this one you can also use for insert. You can also do deep insert. And the rule here is, you see you have books, and the books is compositions in authors, and then in the array, some objects are presented. And the rule is these objects which are presented in the array should be the complete set of data which is contained in the parent entity. So if the entity is not presented here but presented in the data store, then it will be deleted there. If the entity present here but is not in the data store, then it will be inserted. And for entities which exist both here and in the data store, the entities will be modified. And again, you see here, I have used another notation using where and not by key as in the previous example, but for such simple things, this is really equivalent. Delete, I have only one slide showing you can also delete from your entities also using by keys or where, if you have complex expressions. So this delete statement will create you the delete CQN. And I don't know how many time I still have. So this is advanced features already. So I want to show you two advanced features. One is expand. And expand you can do very nicely in the arrow function notation. So at first you see here in the SQL that I not only want to have ID and name, but I also want to have the titles of books which are written by authors. And this is how I can use the query API in order to create the corresponding query. You see here in the parameters, I have two usual parameters, ID and name. And the third one is again arrow function, which saying, okay, for this B, I want to have the title. And this means for books, I want to expand the titles. And you can easily imagine that you can continue with nesting, using the nesting approach here, and you can continue with more and more deep expands using this arrow notation. And for this, it's the perfect thing, actually, the arrow function. And the second advanced feature I want to mention is subselect. Let's imagine you want to have something like you want to select from your authors, but in the condition you have a subselect from some abstract entity test. And for this, I use here the fluent expressions. On the odd place, I have my string exists. And on the even place, I place again a CQN created using the query API. And for this, I just say select one from tests. So this will create me again a new sequen object and insert this on the right place in the where condition. That's basically it about the query API in Node.js. Here are two small examples how you can use it. First one is custom handler. You want to create books, but before creating books, you want to do something special. Okay, you can create a transaction and execute the query which you created here using the query API. Namely, you use the update statement and two functions, with and where, with a fluent notation here and object in with. And another possibility to use this query API is if you want to write your app and you want to request something from, let's say, from OData service. In this case, you again can create the query. And the query in this case is select. You say, okay, I want to select only the column name. And in the where you write condition saying my name is like this string, and this would mean I want to have all names starting with the letter E. And then this query is created. This is a ready sequen query, which you can send for execution here with the next line to the service and obtain your result set. These are two possibilities how you can use this query API in your Node.js application, either as a custom handler or as or consuming the services in your applications. And here is further documentation if you want to know more details about the query API, about the query language. Just take a look into the documentation or into Cloud App Samples, which are also presented here as a link. And with this, I want to thank you and hand over to Matthias. Thanks.
Yeah, thank you, Vitaly. So let me quickly share my screen. So, hi, this is Matthias from the CAP Java team. And in the remaining 10 to 15 minutes, I'll give you a quick glance into the CAP Java SDK query and data API. You should be able to see my slides now. Hope so. Okay, let's start right away. This is just a short disclaimer you already know from the previous presentations, and let's have a look into the query API builder. So on the left here, you see the CDS model you are already familiar with, the books and the authors. And on the right, there is a very simple CQL query selecting the title from the books and then via path or expression, the author name. But while considering the fact that we are already close to the virtual get-together, let's rather prepare for this and select a beer from a brewery. So here we have breweries that have compositions to beers and the beer with association to brewery. Now, from the CQL query you see here, you can just use the Java Query Builder API to fluently write this as a select.from, and then you provide the name of the entity as a string, then .columns, and also here the name of the elements you want to select and the path expression as a string too. Another variant to write this down is using Java 8 lambda expressions, where you, well, in this case, have B that represents the beer, and then you can use get to access the elements of the entity and also the path expressions. And the advantage of using lambda expressions here is that it gives you a few more options. For instance, you can do and define an alias for this. Let's have a look into some more queries using filtering. So here is a SQL query that just selects by an ID. So in case you already know the ID of your favorite beer, using our query builder in Java, you just use the by ID. It provides the value here, and then you don't need to know the exact name of the key element. So we do this for you. We also support query by example style. So in this case, you just provide some example data via map. There you can just put strings to objects. So in this case, a path expression, the brewery name should be Braustübel, the style should be Märzen, and then you can do a select from using matching and just provide the map as an example, and we take this as a query. Now, for more advanced or more complex queries, we also support where conditions. So here in the where statement, you also use lambda expressions. B again represents the beer. You access via path expression the name of the brewery, and this should be equal to Vogelbräu, and the style should not be equal to Pils. So in case this returns too many beers, so then we also support a search query where it would simply select all entries with elements that contain the keyword door keys. Okay, so up to now, you basically saw the dynamic version of our query builder API. So that means for accessing the entities and the element names, you always used strings, like also in the example above. And this has certain disadvantages, especially if your model changes. Then you have to search all your the strings you used in the expressions if they are still valid. And in order to overcome this and provide you with design time checks, code completions, type safety, and also more compact code, we can generate a static model from your CDS model via a Maven plugin. And then you can write this query above just like this, select from beers. And in this case, beers refers to a generated class, and this enables you in the lambda expression to use methods to access the elements and also the associations. Okay, this was a very quick glance into the query API for Java. Let's have a look into the data API. So when designing the data API, we had to look into some SAP application code and also talk to some groups. And one of the major requirements for it was basically to provide type access for business logic. And one way to do this is basically using a plain old Java object. So simple POJOs, these are classes that just represent your data and give you getters and setters to access the data and modify the data in a typed way. But when having a closer look, we also saw the need for extensibility, dynamic access for generic code, interoperability with other code, with other APIs, then conversion to other formats, and these conversions shouldn't be too expensive. And there, actually, the Java map interface, the Java map is actually a good data structure for these requirements. And so now we have both sides. For business logic, we want to have usually typed access. For generic code extensibility, we want to have like a map access for on the data. And therefore, we decided to go for a hybrid approach. So that means we keep the data still in a map, like for instance a hash map, but we generate you POJO interfaces out of your CDS model that you can use via proxy to get typed access to the data in the map. And we also provide you with serialization to JSON in order to make debugging easier. So now have a quick look into how this would look like, how this would work. So here is an example with data, so just a standard map with some data and ID and a style for the beer. then what you can do is you can write your own interface that's for accessing this data via getters and setters. If you want to rename, you can use CDS name annotations to have a different getter, a different name in the getter. For simple non-renaming methods, you don't have to do this. And if you don't want to write these interfaces at all, we also can generate these for you. So now, based on this, with the data and the interface, you can basically access the data using our data API just by writing access. This is a method you can statically import, access data as, and then provide the interface you want to access the data with, and we return you a proxy that enables you to access the data in a typed way. So, for instance, here with the get the style or set the alcohol level. And but still, next to the typed access, you also have dynamic access on the same data using the map interface via get or the put method. So this is basically a hybrid access on the data. Now, this is also enabled for result handling. So for instance, if you execute a query like this on top, so select from beers the style, and then we expand the brewery, and you get a result from this, then you can also use the generated interface to get the typed access on the data. So if you expect a single result, you use the single data. If you expect an optional result, you can use first, and we also support this for lists. So via just list off, then you get a list off in this interface. And if you prefer to work with the Java 8 streaming API, we can also support this via stream off. And then you can, for instance, go on with map, and map here in this case from the beer to the brewery. Okay, so that's basically a very, very quick glance in the Java SDK query and data API, and I guess now we can open up for questions. Thank you.
Yes. Can you hear me? I hope I'm on it. On the struggle with all the volume buttons. Thank you very much. That was a very packed session by you two in 45 minutes, running through all, and well done. We have at least one question that was apart from Vitaly, when the question was that someone is not finding the by key option in the documentation, neither under select and neither under update. Is it something that is coming up and new, or just missing?
Yes, this is a pretty new option.
Oh, Vitaly, your sound is not on. Maybe you're muted.
Hi, can you hear me?
Still not, or I can just not hear you. Sorry.
Hi.
I can hear you.
It's my problem on my side.
Okay.
Yeah, you're loud and clear.
I will switch off my video. Maybe this.
No, it was my. I missed one of the old things.
Okay, then the video is back.
Yeah.
Yes, this is a quite new option. I think in the documentation you can find another method which is called by ID, and this is the next step which allows you not only to filter your objects by a simple ID, but also use object notation where you can place multiple fields, so like working with composite keys and so on. So this option is already there in the CAP Cloud Samples site, which I have presented you, but it's still not there in the documentation site. So sorry, we will update our documentation.
Great. Let's see if we have any other questions. Yeah, maybe it would be nice if we would have some TypeScript generated classes, such like Java. I think that was picking up my question from a very distant view. I was just wondering, comparing the SQL syntax with the query API, and I thought the simple examples look pretty neat and easy to handle. And as soon as it gets more complicated and more complex, it looked like pretty hard to read and put, for example, the where statement in quotations. And I was just wondering how hard this will be in practical life when the statements get more complex.
Yeah, maybe I can jump in here, Daniel. Yes, we experimented with that. I can also share the code for that, and maybe you can help me in the community, generating actually TypeScript lookalike classes that can then be used then in TypeScript or as well as JavaScript, and gives you code completion. And by the way, that is the reason we introduced lately this arrow function approach in Node.js, because that one allows doing code completion, while strings in arrays, of course, don't allow.
Sounds good. Great. We have, let's just quite quick a few. We have some hints and recommendations in the chat, but no other questions. In Vitaly's presentation, I have seen the deep state example referring to equal one inside the book object. I think there were some links in there with the question mark. Sorry, I just need to read the question. Is this double reference needed? What if we use different IDs? What would be arguably wrong? I think Douglas, that's you. Are you able, Matthias or Vitaly, to read that in the chat? Do you get the connection to your session? As a second last comment in the flow.
So I currently don't have connection to the chat. Sorry.
Okay. So we keep that for later on. And one other question: is it possible to apply assert unique to several properties? Especially a pair of two props is a secondary key, and the pair would be unique.
Is this for Node.js or for Java, or in general?
Yeah, I don't have this in the direct. We are picking. Okay. Douglas is doing a model definition regarding the last thing. So the question was: is it possible to apply assert unique to several properties? For example, a pair of two props in a secondary key, and the pair should be unique regarding the model definition.
Right, this is possible. So the idea of assert unique is you can have several, you can express several unique constraints as you know it in SQL. You give them names, and they can have an arbitrary number of columns to be made unique. So you could have assert unique name or assert unique first name, last name combination, like in SQL, basically.
Great. Okay. I think then we are through, and we are pretty perfect in time. Thank you very much. Very good end, and we really like the example with the beer at the end, because it's fitting to your background, Matthias, and it's fitting to our next session on the agenda. So very well done. Thank you very much.
Thank you.
Thank you.
Thank you.
And Volker.